Assalamu alaikum. My name is Dr. Abdul Al-Ghizi. My topic, the high transmission line fault checker with the fuzzy controller of the vocal scanner tracking. Introduction. The inspection of the high voltage transmission line is diagnosed at the time consuming activity that requires the special training technique to work 10 meters above the ground and near level line they carry thousands of the volt. This paper presented development of the tele-operated fuzzy controller vocal sensor tracking checker designed by using the animated mesh vocal and collected the data power line for the prevented the maintenance of the high voltage line. The vocal sensor tracking checker was the design and with the mobile in the mini so that the capable space suspended and all suspend requirement for transmission line have the prevent inspection of the high voltage line will be not be prevented to inspection of the line. The safety operation of the transmission line on component causes the periodic inspection to detect the corrosion and other climatic and the mechanical problem on the flow. Then necessary for the fast and the robust algorithm for the interpreted the photo and the video gotten by the drone during the inspection and has increased the usage for the animated autonomous vocal UAVN college observing growth and use UAVN technique collected the power line data for the analysis defected the various algorithm using for the image processing with the MATLAB and the Python technique. The most common method is mostly used in general effective and many technique and many paper is researcher about for this technique may be for example the paper number 7 and 11 showing the different technique resulting of the electrical insulator simulated crack and the edge detected and also the paper number 12 and 11 13 having described UV technique multi path and detected for the pathing and the two-dimension planning technique. So that in this article we use the vocal as shown in the figure 1 in the next slide. The power transmission line and the distinguish between the line and the conductor insulator to repair and damage, repairing damage or the bladed exchanging of the dissipated of the control line, practical and hard place of the high maintenance. This subject to achieve the power line fault detecting using a drone in the testing and the important subjected to be due to the risk, cost, the time consuming and the difficulty associated with the graphical area and also line and towers. Technical specification of the rule for the fuzzy our drone, that is the point of view vocal robot, this is one, and also the circulating for the drone technique will be depend on the design for the equation number 1 that determine the number of the engine to be used for the safety factor that consider the engine efficiency and typically approaching for the 20% of the total weight heavinesses of the W that is depend on the number of the engine used. And also we proposing using FPGA technique based on the graph and also the high presented to the combined the program based on the assignment by using the hardware report language VHDL and also normalize certainly of the all pixel that will be relative to the setting of the position of the drone where image can be represented there added to the shown in the figure 2 the next slide that will be the equation number 2 to determine the construction of the pixel and the effective the adding the concentration of the neath pore will be depend on the position of the XY coordinate for the pixel located neath pore virgin coordinate and XY. So the rule fuzzy is our regulator depend on the pixel enclosing the neath pore and the maintenance of the interrupted condition. So that this figure is showing the thermal image that to the insulator and thermal image for insulator, and also the processing added and thermal image apply for the resulting algorithm using to process of by using this different technique. Depend on the drone will be have the two type of the camera, thermal camera and also HD camera. The thermal camera already will be taking the wire image that will be useful for inspection the cable and suspected and the electrical connection and switching circuit breaker and across the area. HDR camera working to depend on the take the picture and also checking for the cable. Our transmission line examine system examine all part of transmission line to take a close up to the picture, which we state for the each transmission line part are examined. For example tower insulator, transmission line poles insulator, porcelain or any type of the suspended and adjusted on the external properties of the outer surface, and also skin and check the skin layer for skin layer of the transmission line, checking for the different effective, for example corrosion, and the external parameter transmission line store this image until the image and the data until the external processing by using the MATLAB or Python technique. Our design for the fuzzy PID controller is depend on the pixel surrounding of the net board that will be taken depend on the equation number 2 that will give me the coordinate for the any position of the pixel, and depend on will be design the fuzzy road controller in this table number 2. Resulted and discussion. Overhead power transmission line visual image, this one, and this is the different effective of transmission line component for insulator and transmission line connection suspended, and maybe different effective flash over or corrosion and broken, and also adjusted the corrosion, the different cases. And so that will be insulator broken broken on this one, and also how to processing by the MATLAB technique, image processing normal and defective glasses insulator, and the pixel region normal glasses insulator. This is normal glasses to comparing between the normal and to distinguish which one is defective. For example, by using Python and MATLAB, or when you are using the Python, this is the normal glasses, and this is of the defective glasses, and this is the normal porcelain insulator, and this is the defective porcelain insulator. Figure 50 processing for the normal and the defective porcelain insulator. This is the for processing for the normally and the defective porcelain, and also the region normal porcelain insulator with the Python. Conclusion overall will be resulting that is our paper focusing on surfaces that we detected the external structure for the image, and also the normal insulator and detected insulator having the different surfaces value, and using the detected algorithm with the by using the MATLAB or the Python image tool, or the MATLAB, it takes specific interested the pixel in the image manually, the pixel value of the XY coordinate for the any pixel the film. For example, this is the pixel 130 for the equal to 0 sign normally in the normal classes in insulator, and the one is the in case of the defective. So that in the MATLAB shown in the figure, for example 6 and 7, this is 1, 6 and 7 normal and insulator with the defect insulator and normal insulator, normal insulator and defect insulator, and also and Python technique for the 11 and the 10 porcelain insulator, 10 and 11 porcelain insulator for the different cases porcelain insulator. And also will be the shown in the figure 30 40 shown using the Python technique as shown in the figure 16. In this, the pixel region shown the black and white depend on the edge will be found the image. The white color showing the large number of the arising edge represented by 1 to the 255. The white black color showing the smoothing area represented by 0. In this method must be used the insulator represented normal sample and defective sample for the compare between them to explain which one is different between them. This is the effective insulator may be lead to breakdown because of the fault of the power transmission line that may be cause the stubborn power supply to the consumer. And the suggestion for the future work may be using the drone with the all requirement software and hardware can be using to processing the image to giving the final decision and determine the position the fault. Thank you very much.